Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back, team, and we will continue our discussion. We'll talk about more best practices that we would need to run the application in the container model, right? I hope that things are getting interested, and when I'm covering some of the concepts, right, I definitely focus on the key areas where we should be touch base on that. Some of the basics and other things you can easily get it right when you read through some of the external articles anyway, right? So now. Uh, where we are now. I think we were talking about that our goal is to run an application inside a container, and we are seeing the different ways how we can build a container image and run the container out of it, right? And of course, in this total story that I talked about regarding the containerization, what is the key and the important concept, guys? I would say build process, right? How effectively you can write a Docker file, right? How you can build a Docker container image, that is what is the key point, correct? If you know how you can customize and create your custom container image, then running that image as a container is pretty easy, because I'm not expecting any changes to be done on the running container, correct? If at all you feel that the running container is missing some of the dependencies, or the running container is missing some of the configuration that you are looking for, right? You will never ever go inside a container to make the changes. Of course, if you wanted to do some testing and all, you can do that, but you will never do anything on the running container, correct? Always you need to add your required prerequisites in the Docker file, right? And made create a package out of it, in the sense create an image out of it and run that image in the target environment wherever you wanted to run the application. Are we good with this? That means my statement is, so whatever you are expecting to be available in a container to run the application, you ensure that everything is actually composed it into a Docker file format, and prepare a image out of it. Good. So we went through some of the basics of the Docker container, Docker file syntaxes. That's good. Now let me talk about something. I just wanted to give a small insight about the network concept as well in the Docker, how it is going to be working. When it comes to the Docker networking, right, majorly there are three type of networking is involved: a bridge network, overlay network, and host network. Why do I need to worry about the Docker networking, guys? And of course, right, when a application is running inside a container, I wanted to access this application from somewhere, right? Maybe from your internet browser. How that connectivity is going to your particular container, correct? That is where we need to worry about, or we need to understand how the Docker networking concepts are implemented in order to have an access to the application running inside a container. So usually when you take your Docker host, right, the Docker host is containing a host network. What does it mean by the host network in this context? When I say host network, that is actually the network that is available at your EC2 server level. Hope you get me right. So why I'm calling EC2 every time? Because we are actually using EC2 instances here to configure. That's the reason. But it could be any server where you install the Docker engine, right? That is the base machine, right? The host OS. Your base machine has its own network, right? Maybe if it is AWS context, your EC2 instance is having the subnets, route tables, right? That's how it is connecting to the NAT gateways or maybe internet gateways, something like that. So it has its own network, right, in order to access your machine. That is what I'm referring it as a host network. That is fine, but my application is actually running inside a container, right? So of course, each container is having its own IP address, which we will not be using. Now, in order to access the application running inside a container, right? The Docker has its own networking configured, right? When you install the Docker engine, the Docker is going to set up a, a network, right, within the Docker control, right? So now I'm calling about the bridge network, okay, the way how it works. The bridge network is the default network in the Docker. If you are not doing anything, by default, the Docker will ensure that the bridge network will be set up for you. The bridge network in the sense, by default, all the containers that are getting created in this particular Docker host will be get connected to the bridge network and will be get connected by default. In the sense, my statement now, if you have two containers running in the same host OS, then those two containers can be connected each other via the bridge network that it is managing by the Docker engine. When I say a bridge network, these two containers can connect each other using the name of the container. You don't need to use the IP anymore, right? That's a simple rule. So how one container can connect and access the other container, it will happen via the name of the target container. If you closely look at, right, previously when your application was running in the EC2 server level, we were worried about how we can connect from one server to another server, correct? I have shown you multiple times, right? Or will it's a very general, right? How do we connect from one EC2 server to another EC2 server if at all the both EC2 instances are having some dependency, some file transfer or any other things, right? We usually manage the connectivity from one server to another server using the VPC and the security group, inbound rules, the route tables. That's where we will be working on, right? To give the connectivity from one server to another server. Maybe those are in same VPC or different VPC, so on, so on, so on, so on. But here, right? If one container want to connect with another container for any dependency or any other reason, right? The connectivity will happen using the name of the container, not the IP. Why you should not use IP? Because IP will be keep changing the moment when the container get crashed and created a new container for any reason. But the name will remains be the same, right? And that's how it is. Whenever the whenever you use the name of the container to connect from one container to another container, internally the Docker will take care of resoluting the name it into a IP address. Are we good with this? We know right? Usually the networking terminology, I mean to say, in the networking world, one machine cannot connect with the other machine using the name, correct? Always it should be a IP only, correct? But in this case, right, we are not using the IP address directly. We will be using the name, but the name will be resoluted it into the corresponding IP address of the container, whatever the container is currently running. All that DNS resolution internally handling by the Docker for you. You don't need to worry anything related to that. Now, so that is a bridge network, right? Now the Docker is actually, right, providing a bridge between the host network and the bridge network. The bridge network is actually within the Docker control. The host network is at a EC2 server level. So the Docker engine or the Docker daemon will take care of facilitating the access from the host network to the bridge network. That way, If one container want to talk with another container, that connectivity will go via the bridge network. If the container wanted to access anything outside of the Docker, maybe outside of the EC2 server itself, then that communication come via the bridge network to the host network, then the connectivity go out. Are we good with this? Of course, if you already familiar about the VMware or virtualization, it's kind of the similar concept, nothing much new here. That
But
is what
how
is
the
the
name resolution is happening automatically? That's what I'm not
is
very
what,
clear.
right? So the Docker is maintaining the internal DNS system, which will be storing the IP and the name of the container as a resolution entity within the Docker level, and it will take care of the DNS internally. We will not be doing anything manually to make that happen. So that means, what is it mean by the DNS? DNS is all about, this is the name, what is the IP? Name, IP, name, IP. That is what is called as a DNS system, right? The mapping. This name has to be resoluted to this IP address. If you have that kind of the mapping information, is called as a DNS system, right? So whenever the container is created, what IP got assigned for that container, the Docker will go and pick up that IP. Docker will go on, when I say Docker, it's a Docker daemon, right? It will go and pick up the IP address of the container. It will go and pick up the name of the container. Then it will try to keep that in the internal DNS system as a mapping. So whenever one container is trying to send a request to the another container via the name, so that will be get resoluted using the internal DNS system that the Docker is fully transparently managing. We are not doing anything with that. Right. Now that's the bridge network, how it works, right? Now, if you go to the host network concept, right? So in the host network, the way how it works, right? Your container is directly mapped to the host network. You see the difference? Your container is directly mapping to the host network. In this context, right? At least from the networking perspective, the way how it works, right? It is treating that the application running in the container is actually running in the host machine itself. That is how it will be treated, at least from the networking perspective, not from the application perspective, right? Your application is already isolated. Your application already having its own configuration within the container, but only the networking piece, right? The networking topology will be used by the host network directly. We are not having any more extra networking layer like a bridge network. That is called as a host network, right? So sometimes maybe your application will not happy to work within the bridge network. It may need to use the host network directly. Then we can go with the host network concept too. The other thing is the overlay network, in the sense here you see I'm taking two different EC2 servers or two different Docker hosts. Sometimes the container that is running in one server, right, must need to have an access to the container that is running in the another server. Got me? Right? So one container want to have an access to another container that is running in the another server. In that case, we can set up a overlay network too. Then the containers can communicate each other, right, through this overlay network, though these are actually running in the different servers altogether. It's up to you based on the requirement, what type of the network that you are looking for, then you can go and set it up. Bridge network is the default if you are not customizing the networking components. And if you ask me now, what type of the network that we do use irregular, right, in general in real time, I'm sure at 99 cases we will be using the bridge network only. I haven't used the host network or at least the overlay network anytime. in my experience. Of course, I'm not saying that it will not be in use, but it will be used for certain special cases, but definitely not for the regular applications that we are working on. So that means from the concept wise, you need to understand how these things works. But I think the bridge network is good enough to do some exercises and start using that, right? Which we are pretty much using in real time too. Right, and in the host network you will not be using any kind of a bridging. The container will be accessible as it is directly from your EC2 instance. That means from your host machine itself, right? That is what it is. So that means your container name should be resoluted directly from your host machine itself. Your Docker engine will be facilitating that kind of the network access for you. Okay. So now let me try to do a small exercise on the bridge network alone. I'm not going to do anything on the host and the overlay network, which we are not needed as well to understand how these things will be working, will work out. So we'll see how the bridge network is working. So what I do is I'll just go to the host machine where the Docker is already installed and the Docker is started, right? Now, what I do is I'll run the application. So I think, give me a second. So I think I have the Docker file here, which we have composed the other day, right? Using the Amazon Linux as a base image, and I have configured my own Apache web server on it, right? I'll use this custom image, then I'll try to run a container and we'll see how that gonna work. Okay, so Docker build, I'm just trying to build a image out of it first, right? Let's say this is web, that is the image name, right? I just created an image with the name called web, right? So I'm not following the naming standard, guys, because I'm not pushing my image to the Docker registries, right? Hope you got me, right? So we know how to push the images to the registries. So now I just continue working on the different scenarios. That's the reason I go with a simple name there, not following the full naming convention, because I'm not going to push this to Docker Hub registries anyway, right? Now the image is there. Before me running this image as a container, let me see what are the different networks that are available, right? So right? So if you run docker network list command, it is going to show you the different type of the networks that are available, and you can see that the bridge network is there, the host network is there, and this is called as a none network. The overlay network is not showing here, so look like maybe it's not installed. We need to explicitly define it. So the bridge network is the default network, which we are, if you don't specify any networking there. So it is possible to create your own network as well. Let's say Docker network create, let's say this is a web network, right? So this is how you need to create a network, and at the time of creating a network, usually you can specify the type as well, what type of the network that you wanted to create. So this time, if you don't specify the type, by default the network will be created with your own, sorry, with the bridge type. You see that the bridge is the network type and this is my network name. So all what will happen, right, the Docker is going to use this name, right, and it will set it up the required bridge networking configuration internally for you, right? Now at the time of you are running the container, right, let's say Docker run, let's say this is a web1 as a detached mode, right? And let's say I wanted to deploy the container using the image called web, right? Now we need to specify that the container has to be get deployed and attached to which network out of the networks that are available. I created my own network, right, like this. So let me specify the network name over there. That means this particular container, right, will be get assigned or will be get mapped to this particular network, which is of type bridge. That's it. Now we just try to hit enter. Of course, yeah, this is looks good. What is the flag, guys? Hyphen hyphen network docker ps. Now you see that your container is actually running, but this time the container is actually attached to this particular network. That's it. You don't need to do anything related to the DNS system, all these things the Docker will automatically take care of, in the sense the IP that is assigned for this container and the name of the container that you given, that mapping will be maintained by the Docker internally. Now, whenever you use this name, that will be get resoluted it into the corresponding IP of the container, then the communication will go to that container only, right? So here I use the D flag, that means run it as a detached mode, that means run as a background, or else your container will run in a foreground itself, which I don't want. Good. Now let's say I wanted to run one more container, right? All what you need to do is run the container, maybe the web2, right? And hit enter. Now I got two containers, right? Whenever you specify that the both containers are attached to the same network, you see I given the same network, right? Whenever the both containers are attached to the same network, that's it, automatically this container, the first container, can connect to the second container using this particular bridge network via the name. That's it, you are done. Now if you go to a first container and then try to access the second container, it should work using the name of the container itself, because I said that the both containers should be get attached to the same network. Good. If you want to test this out, maybe it will be little tricky, right? But usually when the application is deployed, right, your application code will know how and why it has to be connected to other containers and all due to the dependencies. The developers usually write a code accordingly. Let's say one application is running in one container, another application running in another container. Maybe it has some dependencies. The developer who is writing the code, they know, right, why it has to connect to another container, right? So accordingly, right, based on the requirement, it can go and connect and do the things. The reason is if you want to test the connectivity, yes, you can do, but the problem is if you do docker exec and just logging into one of the container, right? I just logged into one container. I think this is web2 container, right? From this container, yes, now you should be able to access the web1 container. But to test the connectivity, right, these networking commands are not available here. You see the ping command is not there. If I wanted to see the resolution of this web1, the nslookup command is not there. So basically, let's say it's telnet, it's not there. So basically the commands are not there just to see the connectivity from one container to another container. But yeah, it should work. If you really wanted to test this out, you need to install these right commands as well as part of your customization. I mean to say in your Docker file, right? So you install the ping command or nslookup, whichever the command that you are expecting to be available. Then definitely you can just go to the container and run these commands then it will definitely help you to connect it to that particular target container. Let me exit from there. Let me clear the screen. Docker network list, right? So in general, even you don't need to create a network by yourself. Whenever you deploy the container, by default, those containers will be attached to the network called bridge. You can see the bridge network, right? So this network will be used as a default, but it always good idea to create your own and attach to that specific network that you are looking for. But if you don't create a one, no problem, it will use the existing default bridge network itself. Now, answering to the question that I see in the chat window, right? Usually I'm running the command called exec to get into the shell, right? So here I'm using the bash shell, right? So will it work for all the containers? May not be. Why? If this bash shell is available, if this bash shell available inside this container, then only it will be working, or else no. Right? That's all depends on the minimal OS that you are having inside a container. Getting me? If your minimal OS is having the bash shell, you will get it, or else no. Some minimal OS may have the bash shell, some minimal OS may have the C shell, right? Some minimal OS may have the K shell. You all know, right? The different shells that are available in the Linux system, right? But the bash is the default shell for most of the Linux flavors. But from the concept wise, no, it may or it may not work for all the containers that you are running in, right? If that shell is available, then only it works, or else no. Are we good with that? So which minimal OS that is running there, then we need to see what and all shells that are available there. Then we need to pass the shell name over there. Then only it works to give you the shell to run the commands over there. Looks good. And looking into the question in the chat window, right? The by default, if you are not specifying the network to the container, it will use the bridge network, right? Or else you need to specify exactly which network that you would like to use. If you are using the host network, it will not use the bridge network. The host network will directly give the access to your EC2 instance level. That's how it works. Looks good. Now let me come back to this screen one more time. So I just prepared this simple sheet just now, guys, just to go over at a final, right? So usually when you are running an application, right, the application would need a high availability, auto scalability, some networking configuration. Your application has to be started automatically, right? Your application or the server has to be get deployed to run the application. The RTO means recovery time objective in the sense, let's say for some reason your entire server is crashed. When I say server, that means the compute environment where your application is running. That what is I'm calling it as a server, guys, right? Let's say the compute environment where your application is running is crashed completely. How much time that you take to recovery the server and back the and run the application back? You got me? That is what is called as a RTO timelines. You see the comparison, guys. If your application is running on the virtual servers, let's say virtual server in the sense EC2 in our case, right? If your application is directly running on the EC2 instances, high availability will be maintained by the AWS load balancer. Auto scalability will be maintained using AWS auto scaling group. The networking can be configured using VPC, security groups, routing, subnets, right? The application has to be automatically started and configured, right? That you maintain using the user data that the AWS provides. To deploy the application or a server, you use the AMI, right? Using the AMI, you basically create a new server out of it. RTO timelines. Let's say for some reason your entire EC2 server is down. It got terminated for some reason. How much time that you take, guys, in order to bring it back? At least 5 minutes, because I need to go and create a new EC2 server out of it, right? If the server gets terminated. Now, when it comes to a container model, right? Let's say my application is now running inside a container, right? Do I have the high availability at this time? So for whatever I have discussed, in the sense, let's say I have an application running inside a container. My container is got crashed. Do you think the application is highly available? No. If the container is crashed, if the container is stopped, your application is down. So the high availability is not maintained and it is not available as well by using the native container model. As of today, if you ask me, go and put some high availability, no, it's not supported or it's not available, right, within the native container concept. And the auto scalability, like if more number of users are accessing my application, the required processor memory that is being used by my container not enough, right? Then it has to scale. No, that is not available today, right? So when it comes to the networking, right, how we can access the applications running in the container, that is what I talked about, the bridge networking that you can configure that will facilitate accessing the application, can be outside or from one container to another container. It has its own internal DNS system as well to support the connectivity from one container to another container using the container name itself. The application can be started automatically, right? That is where we can configure the CMD section, the CMD instruction in your Docker file. The application auto start can be configured using CMD or it can be configured using entry point as well. Both are for same purpose, though there is a slight difference, but both are same. When time permits, I'll talk about the differences too, right? Deploying the new server can be done so easily by just using the container image. When I say server, again, don't think that it is a EC2 server. The context here is the compute environment where my application is running, that I'm calling it as a server. In my case, the container is my compute environment, right, where my application is running. So how will you be creating your container? Just a container image. And RTO, let's say your container get crashed. How much time that you take, guys, in order to bring it back? Seconds, probably 2-3 seconds, right? Because everything is already packaged into a image format, right? There's nothing that you need to go and do manually. Just go and run a command. It will just spin up the container within seconds. So those are the few added advantages and slight difference from the process perspective, right? Comparing if it is running on the virtual server, if it is running on the container side. Of course, there are a few other advantages that I talked about: cost optimization, right? Dependencies, configuration, consistency. But here I just scoped out only some technical part. And at least it will help us to get the difference between the virtual servers and the container model, how it is running. Now, the major features that I'm looking for, like high availability
I have a
and the
question.
auto scalability. Sorry.
Yeah, sorry, I have a question here. So can we restrict the resource usage of the host by a container? Like
Yes.
I wanted to say that, okay, it will only use one
Yes.
vCPU or
Yes.
okay.
Yeah. So of course we can tell to Docker that, hey Docker, you please give only this much of processor, this much of memory to my container. Don't give more than that if it is needed. We can do all those resource management, but more importantly, the high availability, auto scalability is not being supported at this time with this native concept, right? Hence the reason we are not really running the container alone to run the application in the real time, because it is missing some of the important features that I'm looking for. It is not only high availability scalability, there are few other added advantages, all those I'm not getting in here, right? Hence the reason we are going to move further a step and configuring our applications inside a Kubernetes. Kubernetes is going to facilitate a few other add-ons on top of the container features. Whatever the container concepts, whatever the container features that you see, all will remains be available in the Kubernetes as well. Additionally, you will get a few other benefits. I did not call out the Kubernetes advantages because we didn't go on to talk about this yet. Because there are few add-ons that we are getting in Kubernetes, right? The way how you are running the application inside a container, right? It includes the high availability, scalability, the efficiency in terms of giving the compute resources to the container, right? All those things are little more matured and right in a Kubernetes. Hence the reason I'm sure 99 cases the people will be running your applications in the Kubernetes only, not like a container the way how I did it just today. Being said that, as we are not running anything as a container directly, as we are trying to run it as a Kubernetes model, right? We don't need to go further deep dive in the container concepts, guys. Getting me? Because this much of knowledge regarding the container is good enough, right? Why? We are not going to use these container concepts as it is to run my application in the real time too. We are using Kubernetes that has its own process. It has its own methods, the, right? All these things will get vary now. So that's the reason now we will jump onto the Kubernetes. Then we'll see what is the Kubernetes concepts to run the application as a container. Then the few other enhancements that I'm trying to put into my application, all those things I'll talk from the Kubernetes perspective, because that is the end goal, or that is the final stage how we are going to use it in the real times. Are we good? That means we talked about how a application can run on a virtual servers, how it can run on a container, but definitely without having this knowledge, we cannot go to the Kubernetes level. But if you ask me what is the final stage, how our application is running in the real time, it will be on a Kubernetes only. That's the reason we'll jump onto the Kubernetes. We'll try to spend more time on the Kubernetes to see the different capabilities that it is offering for us. Are we good? So once the Kubernetes is done, probably I'll come back to the screen one more time. I'll try to fill up the Kubernetes advantages that what we are getting in on top of the container concepts. Then that makes more meaningful as well. When I move further, uh, or when I would like to go further to the Kubernetes concepts, I would like to introduce a terminology called orchestration. What is orchestration? Orchestration is mean that a kind of a management, right? The way how it is going to be managed, that concept is called as orchestration here. The container orchestration in the sense, now we need a better strategy how we can manage our containers, correct? I mean to say, as of today, with the concept that I talked about, we know how to run a container, but do we have a better strategy now to manage my container in an efficient way? No, right? We don't have a high availability, we don't have a auto scalability, we don't have a proper way to manage my application to ensure that it is 24/7 available. We don't have a proper strategy now, right? So that's the reason we need to discuss about the container orchestration concept. In the container orchestration, what is that we are going to do is, you see this slide, guys. We have the host OS, and we are not running the application on the host OS right directly, right? We put a container engine, maybe your Docker engine. Now, on top of this container engine, we are going to install one more container orchestration tool software, right? I'm going to install the orchestration engine in a way. On top of the orchestration engine, I'm going to create my containers. Are we good with this? I'm just putting one more layer of software right on top of the container engine, nothing new here. Why I'm putting the container engine software again on top of the, why I'm putting the orchestration engine? Because the orchestration engine will facilitate the more add-on features that we are expecting to be available to manage our containers in an efficient way by having the auto scaling, load balancers, and few other concepts that we are going to discuss on. That's it. Whenever, or maybe a question for you at this time. Now I'm having a container engine. On top of that, I'm having a orchestration engine too. Now I'm having my containers. Tell me guys, who is responsible here to create a container? At least from your perspective. Which software or which component, which engine is responsible to create a container, right? The container engine is still be responsible to create a container. Maybe a Docker engine is still be a responsible guy to create a container. The orchestration engine will just act as a manager to see what can be done the best for this. The orchestration engine is acting as a manager just to inform to container engine software that hey, when it has to create a container, how many containers, right? How the container can be created. The decision making will be done by the orchestration engine software, but the actual container creation process will still be done by the container engine only. Don't get confused between the container engine and orchestration engine. Both are two different softwares. Being said that, you cannot use the orchestration engine alone to manage your containers. Good. I cannot take out this container engine, guys, right? The container engine must be there. On top of that, I'm using the one other software called orchestration engine, right? That's how it works. Why I'm doing this? And we already talked about these things. What will happen if your container dies? Your application is down, right? If your container is crashed, your application is down. I wanted to scale my computing resources. Maybe the current capacity is not enough. So many people are accessing my application. I'm expecting the auto scale. Maybe it's not supportive as of today. So I need to go to orchestration concept. Even the fourth one is important, right? What will happen when the host machine dies? That means what? Today I have a container running in one server, right? What will happen if that EC2 server is down? All the containers running on that server are down, right? Definitely your application is down. But my expectation is no. Even if the server is down, even if the EC2 server is down, my application should be available. How that's possible? That is where the orchestration engine will facilitate the features for you. So to overcome all these different challenges that we are seeing right now, the orchestration will give you the way to provision and deploying the containers in an efficient way, provide you the high availability and the redundancy of your containers, help you to do the auto scaling of the computing resources across the host machines. That means orchestration engine will facilitate to manage the containers in multiple host machines as well, not only a single machine. It will provide you some of the load balancing and the service discovery features, which we will be discussing later. And the more importantly, the orchestration will help you to do the health checking as well. That means the orchestration engine can keep on checking the health status of a container. Let's say the container is not healthy, it will immediately go and restart it. Let's say your container is not healthy, your orchestration will stop the traffic to that container. Getting me? Right? If someone is accessing the website, right? If that request is going to the container which is currently not in a healthy state, the request will fail. So it will try to ensure that only the healthy container will receive the traffic. The unhealthy containers will not receive the traffic. All those health checkings can be done by this orchestration engines too. And obviously it will give you more matured networking concept, which will help us to have the connectivity from one container to another container in an efficient way. Now, if you see the container orchestration tool here, that is where we need to use the Kubernetes or Docker Swarm. Okay, that means what? What are the different softwares that are available in the market, which will be working as a orchestration tool, right? So one is the Docker Swarm. Docker Swarm is the one of the orchestration engine software that is provided by the Docker itself. The Docker company itself is giving you a orchestration engine like a Docker Swarm, right? Docker is a native Docker, which we have discussed so far. Docker Swarm is the orchestration engine which we need to use if you wanted to utilize all these orchestration features. Mesh OS is one of the orchestration engine software that is given by the Apache organization. Kubernetes is the another orchestration engine which will give you the orchestration features provided by a Google company. So these are the different orchestration choices that you have, which you wanted to use on top of your container engine. Now, definitely out of these three, right, the Kubernetes has more weightage, which has more powerful, right, features that are supporting for the real-time environments. So I'm sure 99.999 cases the people are using Kubernetes only because it has that much of beautiful features compared to any of the orchestration engines. Being said that, obviously we will be now targeting to see how a Kubernetes is acting as a orchestration engine to give us the add-on benefits to run an application inside a container. Are we good with this? Super. Now let's see what is Kubernetes, how the Kubernetes is helping me. So far we know that, right? So far we know that you actually pull a image from the Docker Hub, then you run a container by running the Docker commands. The Docker engine will take care of creating a container for you and giving the required computing resources to run the container, right? So usually when you install the Docker engine, it is actually installing a few other dependencies as well, correct? Have you ever observed that it is actually some of the dependency packages when you run install Docker, right? When you install install Docker, sorry, when you run install Docker, it is not only installing the Docker, right? It is installing a few other dependency packages as well. Out of them, container D is one of the packages, shim is one of the packages, runc is the another package. These are the some of the dependency packages that will be installed automatically along with the Docker, guys. We don't need to know deeper, but I'm just trying to put this slide as well just to get some context. You all working at a Docker engine level because you are using the Docker commands, right? But internally, your Docker commands are making use of container D daemon, making use of the shim packages, making use of the runc packages. Then finally, it is taking the help of all these different layers. Finally, your contents will be created. But we are not worrying any of these internally because that takes care of, Docker will take care of all these things, right? Why I'm putting this in a picture here, because we should not assume that the Docker is doing anything. No, the Docker is actually doing the container creation process with the help of few other dependency softwares that you see in this layer. Runc is the actual software which is actually creating a containers. Container D is the actual daemon which is taking care of the majority of the work here, how to create a containers, all these things. Then why we are not working with the runc and the container D? Why we are working with the Docker? Because the container D is the actual daemon who is responsible for majority of the container creation process. But the container D is a low level program. What is low level program, guys? Low level program in the sense you as a human, you cannot work with the container D directly because it expects the given instructions to be in a different format, maybe a low level ASCII format, or it could be machine understandable language format. Getting me? It's not as like Docker run command, right? It is very complex to work with the container daemons. That's the reason the Docker people has made a wrapper on top of these low level programs and given you the flexibility, right, to run a commands at a Docker layer. So when you run the Docker run command, the Docker run command will now go and talk to the container D, will translate your instructions it into a different format, how the container D is expecting. Then the container D will take it and proceed further to the next level, and then finally the contents will be get created. That is what is happening behind the screen. Is mean that let's say if you know how to work with the container D daemon directly, okay, let's say if you know how to work with the container daemon directly, then do I need to use Docker engine? No. Then you don't need to use Docker engine. You directly install the containerd package only, then you work with the containerd only. Right? If you know how to work with the containerd daemon directly, you install the containerd package, you start the containerd package, service, then you try to work with the containerd directly, then you don't need a Docker. But it's very hard to work with the containerd directly because that is expecting the input in a different low-level programming language. Getting me? That's the reason that Docker has put one extra abstracted layer. Then the Docker is taking care of how to talk with the containerd and other low-level programs. Docker has given you a beautiful, nice commands. You use the commands. Let the Docker handles behind the screen to talk with these low-level programs and all. Getting me? Right? Now, you see this slide, guys. I'm slightly changing these things. So can I replace the Docker engine with the containerd? Can I do that? I'm not using Docker now, right? Rather me installing the Docker, I'm directly installing my containerd. It should work. It should work. Why? The containerd is the one which is actually doing the majority of the work to create a containers, all these things. Docker is kind of a wrapper, abstracted layer, which is just facilitating the easy way to manage and interact with the containerd. So that's the reason I am just replacing my Docker engine with the containerd itself directly. But I can't work with the containerd directly, right? Because that is expecting the low-level program. So now can I say the containerd is the container engine? Can I use the terminology called containerd is the container engine? Obviously yes, right? Previously I was saying the Docker engine is the container engine, right? Of course that is true, but now containerd is the container engine. I'm just removing this Docker abstracted layer, that's it. Of course I can't work with the containerd directly, but now you see the Kubernetes engine. On top of my containerd container engine software, now I'm installing a orchestration engine called Kubernetes. The Kubernetes will know how to work with the containerd. Kubernetes know how to deal with the containerd and how to make the things happen. So now you always work through the Kubernetes. Kubernetes will give you the beautiful commands because the Kubernetes is acting as a abstracted layer on top of the containerd along with the orchestration features that you are looking for. So whenever you are using the Kubernetes engine, right, you can use the containerd as a backend container engine, and you always work with the Kubernetes. It will handle everything behind the screen to talk with the container engines and create a containers, all these things. Are we good with this now? But nothing is changing. Everything is gonna be the same, guys, right? What I have done so far as a Docker, what I'm doing going forward, everything gonna be the same. Nothing is different. The reason why I'm spending some time here, because the Kubernetes has announced a news saying that the Kubernetes is announced a news saying that We are not using a Docker engines as a backend to manage the containers. Instead, we are using container D. That is the news that is out from the Kubernetes guys. That makes sense, right? Why the Docker engine should be there when the Kubernetes know how to talk with the container D directly. Right? For the reason I'm just spending some time to make you all this context. But at the end of the day, you will never worry about container D. You will never worry about Shimpy packages or RNC packages. You just work at a Kubernetes layer that will take care of how to deal with all of these backend things. And again, you don't need to worry about what is shim package, what is runc package, what these are doing. Getting me? If you want, yes, we can go in deeper as well, but nothing that we get out of it, because we will never ever work at that level how these things are working. That is all level, that is all low level programs. Now looking into the chart window, Kubernetes will never ever work as a container engine. Kubernetes will never work as a container engine. Container engine terminology means that it has to own the responsibility of creating a container. Kubernetes will never take the responsibility of creating a container directly. Kubernetes is just a orchestration engine which is facilitating a manager role to decide what to be done. The Kubernetes will take the help of container engine software like a container D to get the containers are getting created. So my
So
statement
even the
is,
pull and push will happen through container D, right, sir? Like the pull from the Docker hub and all the images.
of course, of course. Now I see one more statement there. That's true. We will never use any Docker commands so far. Now onwards. Okay. Of course, there and there we will use the Docker command, but yeah, I would say yes. I will not use any Docker commands from now on. I'll use all the Kubernetes commands. Let Kubernetes handle behind the screen how that the things has to be get deployed. Getting me? Even the pull, right? Even the pull command, I will not use Docker pull command. Let the Kubernetes handle how to deal with this. We will get to know all this, but yeah, now onwards I will not work with the containers directly. I will work at a Kubernetes layer. Let Kubernetes handle or deal with the container engines behind the screen. Yes. So far we are actually dealing with the container engines directly. Now onwards, we are not dealing with the container engines directly. Rather, we deal with the Kubernetes orchestration engine that will take care of talking to the container engines behind the screen. This is your final slide. This is again whatever I have discussed, right? The Kubernetes is a orchestration engine which is facilitating all these different beautiful features. Now you see again, guys, there is a container engine which is a container D. On top of that, I have a Kubernetes engine, which is the orchestration engine. Good. So I'll take another presentation here to go over with what is the Kubernetes, how it works. Today, I'll talk about only the theoretical discussion. I'm just trying to make understanding these terminologies and what the Kubernetes is. The actual implementation will happen maybe start from tomorrow. Right? That's the reason I spent a time on a container concept, because once we know what is the way or how the container concepts are working, it's very easy to work at a Kubernetes level, because the Kubernetes is acting as like a abstracted layer which is talking to the container engines behind the screen. You work with the Kubernetes, Kubernetes go and talk to the container engines. Of course, we'll go to the specific questions at end of the lectures again. So probably this slide will cover a few other details, right? I will take a EC2 instance where I wanted to run my applications inside a container, but always I'm looking for the high availability, right? If my EC2 instance gets terminated for any reason, again guys, when I'm referring EC2 instance is mean that your host machine, okay? If your host machine gets terminated for any reason, all the containers running inside the host machine will be get down and your application is down, but we don't want it to be happen. So how that's possible? Instead of using one host machine, you better use multiple host machines. Then the problem is solved, right? When you have multiple host machines, then if one host machine is terminated or down for any reason, no worry, my application can continue to run inside a container running in the another host machine possible. So if you are expecting the high availability in terms of the host machine failure, then you take multiple host machines rather one. I'm talking about the Kubernetes architecture now, how the Kubernetes is handling this whole concept. It's up to you. You wanted to use one host machine or 3 host machines or 50 host machines. It's up to you. Based on how much high availability that you are expecting, you can put a multiple host machines based on the budget that you have, based on the expectations that you have, the load that you have, and keep all these different host machines to the Kubernetes, saying that, hey Kubernetes, these are the 3 host machines that I wanted to use to run my application. If one is down, you take care of running my application in another host machine. Good with this? Kubernetes will handle this. If one host machine is down, how to run your application in another host machine, in another container, all those things, Kubernetes will take care of it. You just need to tell that you please maintain these host machines and run my containers without having any downtime. And that's where now I can see a interesting question. Why don't we use all of these host machines in one container? That is the question that I see in the chat window. The container will be inside a host machine. The host machine will not be inside a container. Okay, right? The containers will be inside a host machine, but the host machines will not be inside a container. Okay. Now, from the terminology wise, the host machines are now called as a worker nodes. Host machine is the container level terminology. We already done with the container concept, right? I'm done with my Docker concepts. Now onwards, the host machine terminology is changing to a term called worker node. So from understanding perspective, yes, host machine, worker node, both are same. Worker node is the terminology which is very specific to the Kubernetes. That's the reason I'm now using the term called worker node, guys. Are we good with this? I will not use the term called host machine from now onwards. I will just use the worker node concept. Worker node in the sense the actual host machine where the application you are expecting it to run. Your EC2 instance is now called as a worker node. When you have multiple worker nodes where you are expecting the application to be running always, like if one worker node is down, my application to be running in the another worker node, that is the expectation, right? When you are expecting this to happen by the Kubernetes software has to be installed, right? Somewhere. You take a one more EC2 instance, that EC2 instance is now called as a control plane node. This EC2 instance is called as a control plane node. In this control plane, you need to install the Kubernetes software. The Kubernetes orchestration engine software that you are installing in the control plane EC2 server, that will be taking care of managing the worker nodes. Good. That means I'm going to take a one more EC2 instance which is called as a control plane. In that I'm installing my Kubernetes component. Then the Kubernetes will take care of how to manage your worker nodes, right? How to run your applications, all these things. So now I have how many instances, guys? Total 4, right? Because I'm maintaining multiple instances to make this whole best practices are applied, right? The collection of multiple EC2 instances, the collection of multiple servers together called as a cluster. Here I have multiple servers, right? Together all the servers called as a cluster. I would say like I have a Kubernetes cluster now. What is Kubernetes cluster? Kubernetes cluster is a terminology that we use which is consisting of bunch of or multiple EC2 instances put together to run as one single cluster kind of. I would say now I have a Kubernetes cluster with 3 worker nodes. That is my terminology, right? I have a Kubernetes cluster with 3 worker nodes. I have a Kubernetes cluster with 1 control plane. That's how we use the term. The cluster means the combination of the multiple servers that we are putting together to make it as a orchestration engine.
So how will you maintain the high availability of this control plane node? Let's say the control plane node fails, then everything will fail, right? The orchestrator will fail.
We'll see that, right? Now, when you install the Kubernetes software on the control plane, right? API server is one of the service that will be get installed, that will be up and running, like any other services, right? Docker service or any other. So API server is the name of the service, right? API server is the name of the service that is installed, that is up and running. This service is more responsible to handle how to interact with the worker nodes and how to instruct the worker nodes what needs to be done. The thing is, the Kubernetes is the orchestration engine, right? Which is doing many things for us, which will give you the health checking of the containers, right? Giving you the high availability, load balancing, networking, and various other features as well. All these features cannot be handled by a single service. So when you install the Kubernetes software, it will install the API server service, that is one of the primary service right? And it will also have the services like a scheduler service. This is another service. Okay, the scheduler is the one more service that will be get installed, right? There will be one more service called control manager. There will be a one more service called etcd. There will be a one more service called cloud control manager, like that. Why this many number of services? Because the whole concept is heavier, right? All these things cannot be managed by one single guy. So the combination of etcd plus control manager plus API server plus scheduler plus control manager, cloud control manager, right? All this together called as a Kubernetes software. Getting me? All this together called as a Kubernetes software. Maybe previously when you were installing any softwares like Apache web server software, Docker software, or any other, right? You are able to see only one service. That's the reason I'm putting some effort here. When you install the Kubernetes, it's not a one service. It has multiple services, right? That you need to bring it up. Each service has its own responsibility, what needs to be done, and that's how the Kubernetes is working. Out of all this, API server is the service which is the core service in the Kubernetes control plane, which is doing a majority of the job. All the other services like a scheduler service, etcd, control manager, other thing, all these things are actually reporting to the API server, right? All these other services are reporting to the API server service. The API server service is now the responsible guy to communicate with the worker nodes and inform to worker nodes what needs to be done. That's the reason API server is the main component in the Kubernetes control plane, which is doing the major job. Why? That is the one which is talking to the worker nodes and informing to the worker node what needs to be done. You have installed the Kubernetes software on the control plane, right? That is fine, but there should be someone at a worker node as well who can listen to the API server instructions and follow accordingly, right? So in the worker node side, you need to install a software called Kubelet, right? Kubelet is the software that you install and you bring up this service in the worker node. That service is responsible to listen to the API server. Then whatever API server is telling, it will just follow it. So let's say API server tell that, hey, worker node 1, you please create this so and so container. The information will go to kubelet. The kubelet will receive the request, right? Then the kubelet is the responsible guy to go and talk to the container runtime. What is container runtime? Container runtime is your container engine, like a container D. Okay, we spend some time, right, in understanding the container engine terminology, right? So the container engine, like a container D, is the responsible to create a container, right? So here the API server is telling to kubelet. The kubelet will go and talk to container runtime, right? The information, whenever the kubelet says that, hey, please create a container, then the container runtime will go and create a containers for you. Where is the container? That's okay. Then your container runtime will go and create a container for you. That's how the containers will be get created on the worker node. Now tell me guys, out of this whole flow, who is responsible to create a container? Is it Kubernetes? No, right? It is still be the responsibility of a container runtime or container engine. The Kubernetes, which is the API server in this case, right? is just a responsible guy to decide what needs to be done and inform to kubelet in the worker node. That will go to the container runtime. Finally, that will be taken care of. The API server is now deciding, let's say you want to run your application as a container. The container to be created in a worker node 1 or worker node 2 or worker node 3, where exactly the container has to be created, that is something will be decided by your Kubernetes control plane. Getting me? Because now I have 3 servers, right? We don't know where the container has to be created. Let the Kubernetes handle automatically. How the Kubernetes, when I say Kubernetes, the control plane kind of software components, how it will handle, how it decides that your application to run on which container, sorry, which worker node. I have 3 servers with me. That is where you can see the control plane, right? In the control plane, you see a service called scheduler. Scheduler is a service. That service is responsible to analyze how many worker nodes that we have, which worker node is the best to run my application. It will verify how much processor and memory that it needed to run the application, which EC2 server has enough processor and memory capacity. It will try to do some checklist. Finally, the scheduler service will decide that, okay, worker node 1 is the good choice to run my application. That's how the scheduler will decide it. Once the scheduler service is deciding your application has to be deployed it into which worker node, then the scheduler will inform that to the API server services, saying that, hey, I did some research, I did investigated on the worker nodes. I think so and so worker node is the right choice to run this application. That's how the scheduler is giving that report to the API server. Then based on that information, API server is going and talking to that particular worker node and informing that, hey, you please create this container. That will be taken by the kubelet. Kubelet will go and talk to container runtime. The container runtime will go and create a container for you on that particular worker node. Now, in this context, do you think the scheduler is acting as a load balancer? Where it is working as a load balancer? Scheduler is a service that is running inside a control plane EC2 server, which is responsible to decide your application has to be running in which server based on the resource availability and other component. The load balancer terminology is all about routing the traffic. Okay. Load balancer terminology is all about routing the traffic. It is not routing the traffic. It is just deciding which server will be the best to run the application. The traffic routing is not done here. Yes. To make this whole working, right? In the control plane side, we need to install etcd, control manager, API server, scheduler, all these things. The kubelet is the only one guy that we need to install it in the worker node side, because that has to be communicated with the API servers. Well, let's say the scheduler service is decided that which, of course, as a CA chart window, right? The scheduler service is following some algorithm, some logic. Then it is deciding that which worker node is the best. It will inform to API server. API server will inform to that particular worker node. Then finally the container is created, right? How would that container will be accessible, correct? From maybe within or outside, whatever it is. Kubeproxy is the another service that is installed running on your worker node. The Kubeproxy service is now responsible to facilitate the networking between the worker nodes, even to access this application from outside of this Kubernetes concept to your external world. Sometime back I talked about the Docker network, right? The Docker network will give you the bridge network. It will help you to route the or map the network to your host machine, then you can access it. Same thing here, the Kubernetes using the concept called kubeproxy, which will be facilitating the networking configuration, all these things behind the screen for you, so that the container that is running in one worker node can connect with the container running in the another worker node via this kubeproxy, even to connect it from outside world. All these things facilitated by the kubeproxy services. When I have installed a Docker and have done the port forwarding, I have shown you that in the host machine level, if you do a netstat command, the port number is actually being listening by the Docker proxy, right? What is the responsibility of the Docker proxy over there? The same thing is now being taken care by the kubeproxy here. Now that's easy to understand. It's not a security group, right? Security group is different meaning. That is actually filtering the traffic, decide what to allow, what not to allow. Proxy is a different meaning, right? Yes, we need to install the kubeproxy as well on your worker node side, which will be facilitating the communication part. Of course, I'm happy to take a pause and take the question there. As per the question, do you think the kubelet is actually serving the traffic? No. Kubelet is the responsible guy to listen to the API server instructions that are coming from the control plane server and talk to the runtime and ensure that the containers are getting created. Kubeproxy is the responsible guy to facilitate the networking between the worker nodes to talk to different worker nodes, right? And giving this access to the outside world, all these things. So technically the port forwarding in the Docker, the port forwarding that I did it, right? That a port forwarding kind of a functionalities will now be taken care by the kubeproxy when you are using the Kubernetes. Strictly speaking, the kubeproxy is going and talking with the Docker proxy in the backend. And I say Docker proxy, some container proxy configurations. Yes, the kubeproxy is kind of replacement to your bridge network that you know you used some before. It's kind of not exactly. Yes, it's kind of. Yes, the kubeproxy is just for giving the communication between the worker nodes and to outside whatever. It will help you to provide a communication basically, right? And it won't work directly, but we need to do a lot of things on top of that. But basically, yeah, that is the one which will be giving you the networking communication. Now, yes, as I see a question again, yes. The kubelet will be connecting to the control plane node to receive the instructions from the API server. It is not facilitating any other communication channels for you, no. Right? I see a question there, guys, proxy, is it replacing the bridge network or overlay network or host network? Don't go in deeper on all this. Whichever the network that you like it will be replacing. So pretty much the proxy is the replacement for the Docker network. Let it be a bridge, let it be a overlay, let it be any other. The proxy is actually facilitating the Docker network, or it is a replacement for the Docker network at a high level terminology. Right? Now, the thing is, now tell me guys, how easy or difficult to set this up? If I ask you, hey, go and set up this, you create the 3 EC2 instances as a worker node, 1 EC2 instance for the control plane, you create total 4 EC2 instances. Then you go to the control plane side, you install all these softwares, you start all the services, you go to each and every worker node, you install the kubelet, proxy, and the container runtimes, you start all the services, then you manage the networking, right? The control plane should be able to communicate with the worker nodes, because I'm working at a server level, maybe a security group, all these things to give the connectivity. A lot of things are there. This is not like a one time, like one command that I go and run it and working. No, significant steps are there to configure the Kubernetes cluster. Yes or no, guys? Yes, the kubelet, proxy, scheduler, API server, etcd, all these are the services running on your EC2 server level. Let's say somehow you go and set up everything, you install all the components, all the servers are there, everything is ready now. Now my goal is, I have a Apache HTTP application that I wanted to install and run inside a container. That is my goal. Now, where do I need to start with? Correct? Tell me guys, where is your application actually? So can I use the statement, right? You already performed a build process, the container build process. You created a image out of it, correct? That image now I wanted to run as a container. That is my goal, correct? Till Docker file and building the Docker file and creating an image, that is pretty much same, that I'm not changing anything. Once the image is ready, then I'm struggling a lot, right, to ensure that the image is deployed running as a container with following all the best practices, including the high availability scalability, correct? So once the image is ready, then how we can make sure that all the best practices are followed by using the Kubernetes? That is what we are going to discuss now. So that means what? By now you have the image with you, correct? Now your image has to be get deployed as a container in the Kubernetes cluster, correct? So once your entire setup is done, now I need to inform to Kubernetes, right? Hey Kubernetes, I have the image with me. Maybe in the Docker Hub registry, I have the image. Can you please take this image and run it as a container? That is my expectation, correct? So all what you need to do is, you as a Kubernetes administrator, right? You as a Kubernetes administrator, You use the Kubernetes commands like kubectl. Kubectl is the command that you are going to use here to interact with the API servers. Kubectl is the command that you are running as a Kubernetes administrator to run the commands. That kubectl command is going to interact or connecting to the API server. Then whatever the requirement that you have, let's say I have an image and please deploy this as a container. That is your requirement, right? You give the details in the kubectl command only. In the command you mention that which image that you are looking for or which image that you wanted to run as a container. You give the image name, you give the details, everything in the kubectl command, you run it. The command will go and talk to API server. That command will give the information to API server, hey, this is the image I wanted to run as a container. Then the API server will take the help of scheduler. Hey scheduler, tell me, I wanted to run a container using this image that the user has executed a command. This container should be get created in which worker node. The scheduler will go and do some analysis. It will try to identify the worker node, then inform to API server, hey, this is the worker node where this container has to be created. Then the API server will go and talk to the specific worker node, inform to that, hey, you please create a container using this image. Kubelet will receive the information, will go and talk to the container runtime. The runtime will actually go and create a container using the image that is being said. Finally, your container is running over there. So kubectl is now the replacement for your Docker commands. Previously, I was running the Docker commands, right? The Docker run, Docker exec, Docker images, or whatnot. So the Docker commands are now replaced by a kubectl command because now I'm interacting with the API server component, which is running in the control plane node. Kubectl is not connecting to the image registry. Kubectl is only connecting to the API server. Kubectl is only connecting to the API server just to give your input to the API server. Your requirement is, hey, have the image, can you please run as a container? That instruction will be given to the API server using the kubectl command. Then the API server will take that input, will take the instruction, it will process it, and finally your work will be done, or your container will be get created, right? Of course, as I see a question in the chat window, before you running the kubectl command, not only a control plane node, not only a worker node, your entire Kubernetes setup should be ready, right? Getting me? Your entire Kubernetes cluster should be ready. When I say cluster, control plane, worker node, connectivity, services, everything should be ready. Then you use the kubectl, inform to API server, hey, please run the image as a container. That will take it up. And it will decide where to run, how to run all this. Now the biggest question here is, whenever you run a kubectl command and you inform to API server, hey, please create a container. I have the image with me. This is the image. Please create a container. How would API server know that it has to connect with the which worker nodes? How to connect with the worker nodes? What are the worker node IPs? Which is the port number that it has to use to connect with worker node? You got me? A lot of questions, right? Let's say in your account you have some 50 EC2 servers, right? How would your control plane know that it has to connect with which EC2 server to run a container? So how many worker nodes that you wanted to use in this cluster, all those worker nodes must be registered with the API server. When you create a worker node, right, the kubelet should go and register with the API server. Hey, this is my IP address, this is the information about me, and please register me. So that's how the each worker node should go and register to the API server. Then the API server will take the information of the worker node, the IP and other information. Then that information will be get stored into a etcd, which is acting as a database. That means in the etcd database, it is storing all the information about the Kubernetes, like how many worker nodes, what are the IPs of the worker node, how many containers, where the containers are running, how many containers are running, kind of all the information is available in the etcd database. So whenever the API server wanted to connect and manage the stuff, right, it will fetches the information from the etcd database. Then it know exactly how to connect, where to connect. Then it will try to inform to the worker nodes. All this will happen. We are not doing anything manually. Whatever I'm talking, everything will be handled by the Kubernetes, but I'm explaining the flow process, how each component will be working behind the screen. If your worker node is not registered with the API server, then it will not be there in the etcd database, and your API server will not manage the worker node. So every worker node must be get registered with the API server. Hey, I wanted to register with you, and I'm there to run the containers. Then only your API server will consider that worker node to run the applications over there. I think I see a question there in the it's not a question, kind of a conclusion statement there, saying the worker nodes are acting as a ship in the port where it is carrying the containers, and that is a good thing, right, to understand. So that is the reason probably if you see the Docker, yeah, interesting. I have the Docker here. Usually you see the Docker logo, guys. The Docker logo itself is telling you that the Docker logo is kind of a ship where it is shipping multiple items in it, right? So that logo itself is telling that the Docker, of course, when I say Docker is a container concept, okay? Don't get confused. Why I'm going back to the Docker? It's a container concept. The container concept is all about, right? You build a image, you ship the image, you run the container wherever you wanted to. So this is called as a building, shipping, and running the container. That's the three terminologies that the people use to, right, related to the container concept. You ship the images, you run the containers, and that's how it works. Yeah, you see that your containers are now running in the worker node. That's it. That's the story, guys.